So my topic today is actually our ongoing project, predicting inner quality of Scotch pine logs during harvesting. And this is a cooperation project between the University of Eastern Finland and Luke, funded by Tekes EU and companies. And since we are combining here research expertise from several areas, I would like to introduce our team. So at Luke we have Jukka Antikainen, who is mostly focusing on this image analysis part, and actually he was supposed to be here first, but he couldn't come. And then at Luke there is also Jori Uusitalo and Heikki Korpunen, who are more on developing this quality prediction model. And at the university, in addition to myself, we have my colleague Markku Tiitta, who is then focusing on the development and the electrical impedance spectroscopy technique. So we have a 2-year project, which is now about halfway through, and I am going to show you what we have done and what we are about to do in this project. So first, about the quality of Scotch pine logs. We already talked about the quality this morning, and there is 3 main factors that can be used for the prediction of, especially I am now talking about the butt log quality. And of course the diameter of the trunk is one parameter. Then another one is the dead branch height. And third parameter is this early growth rate. And in this graph you can see how the probability of getting high quality butt logs decreases as a function of early growth rate. And there the different lines represent different butt log lengths. So if you want to get only a shorter log, the probability is higher than if you want to get more than 6 meter log. So this is the background and basis for this project. I found this research paper where it was concluded that the combination of these 3 parameters would be the best way to predict the quality of Scotch pine. But since the last parameter, the early growth rate, it is not very practical parameter to be measured in the forest. Traditionally you would have needed an edge auger or such device to do that. So now we are trying with these new technologies provide parameters for those quality prediction models. And we are testing and developing these methods, which include imaging and image analysis from the end of the log. From those images you can get the bit location, the width and orientation of the earring, defect locations, and then this early growth rate. And then we are also testing electrical impedance spectroscopy, which is those parameters from that technique are mostly related to the moisture content and density of the wood material, and thus it can be used for evaluating the hardwood, sapwood and decay in the wood. So what we have been doing last summer, we had this field testing, and there we had 6 stands that were marked for cutting. There were selected trees that were taken into this study, and they were characterized beforehand. So the height and the diameter dead branch height were recorded, and then they were cut, and then the logs were imaged from both ends. We had almost 200 trees there, and then some of these trees were further measured with the electrical impedance spectroscopy, and then the logs were taken to our industrial partner for X-ray scans. And here is the imaging, so just taking pictures from the log ends. and each image includes the specimen number and meter, and this is the basis for the image analysis then. The electrical impedance spectroscopy measurements, they were done separately. So we have this chainsaw which has electrodes attached into the guide bar, and this measurement is done while cutting the tree. And so from the ends of the logs we got discs, and the measurement was done simultaneously. And there we need a small box for the electronics and then a laptop to make the measurement. Then after the X-ray scans, some of the logs were taken to saw, and 75 parts were sawn from them, and the number of knots and defects was manually determined. There was about 1,400 of them in total. So this is for the reference for the other methods. And so this was the data gathering, and then we have the images. And what happens now is that the images are divided into smaller blocks, and Fourier transform is applied to each block, and from this we can get the direction of the frequency energy distribution, which is there marked by the blue arrows, and the bit can be found in the estimated cross-section of those arrows. And this is the basis for the further analysis. Here are, I hope you can see the red dots in the middle of the log ends, so they are the estimated bit positions. And as you can see, it doesn't matter if the log is circular or not. What happens then is that the image is transformed into polar coordinates, and from this polar transformed image on the right hand side, you can then analyze the y direction to get the growth rate, the shape of the log, and the hardwood content. And now especially we get the early growth rate for that quality prediction model from this data. Then we have the electrical impedance data, so we are measuring the electrical properties of the wood material, and actually with this chainsaw measurement we had some challenges, surprisingly, in the forest. So while we can get a nice contact between the electrodes and the wood material, the contact was a bit too much for the connectors to the electrodes, so we needed to fix it between the measurements, and thus in the end we decided to take some of those discs with us to the laboratory and make the measurements again. So we have this online system which can be used to, it's a conveyor where we can measure things, and the speed of the conveyor was adjusted so that it would be relevant for the sawing speed. So this data then presents the inverse of the impedance. So the blue line shows the peaks in that blue line are actually sapwood. There is very low impedance because there is lots of water in the sapwood, and then hardwood can be seen as a pit in the middle. The impedance is higher, mainly due to the moisture content difference. And this measurement is done along the line of the ruler in those images. So now we have a large set of data. We are going to start the statistical analysis. We can combine the information from the stands, from the X-rays, from these images, and from the electrical impedance spectroscopy. And we have seen that there are some challenges. For example, in some images you can see the pattern caused by the saw, which is like stripes over the image. But that should be possible to filter out. And then, for example, for this impedance electrodes, we have been using the same type of electrodes in wood industry, online systems for year around. So we are quite confident that we can build durable electrodes if we have enough time, which we didn't have at this point when we started the measurements in the forest. So this, all this data is also then used for the development of that quality prediction model so that it will be improved. And hopefully we get to do another test set next summer, probably with less specimens, but anyway we would like to verify our results then. And related to this development, we have also another project, both at the Luke and at the university. So there is this project called Value Addition of Spruce logs by novel technological applications. It is very similar to this project, but focusing on spruce and on spruce quality issues, which are quite different from Scots pine. Jori Uusitalo is the leader of that project. And at the university, we have a project related to these novel sensor techniques for bioeconomy, where we are also developing these sensors for electrical measurements and ultrasound measurements, so that they would be more affordable and more durable and suitable at different conditions. And also we would like to use our sensors so that we can get data from matrix setups, and we will be able to measure broader areas, such as Venner, for example. And in this project we are focusing on pulp and energy applications, so we are measuring wood chips and forest chips, for example, and then on the other hand on the mechanical wood products. And these three projects get quite much synergies from each other, so I think we can get nice development work done with these ones. Thank you for your attention.
Thank you very much, Laura. So now it's time to questions. So I would like to know that, are you thinking about using also the multispectral imaging when you are making those reference images?
Jukka is possibly thinking of that. Yeah, maybe he would be the right person to answer that.
Okay, but there is not yet done.
No.
How, in the possible final solution, how would you take the photos from the log end? So, is there someone who walk beside the piles, or take the photos in the forest, or where you are going to put the camera?
We would like to take the photo right after the cut, so it should be integrated into the harvester, so that we would have the information before the next cut is made. So that's the ultimate goal.
Have you done it?
No.
Continue question is that when you can do it?
It's beyond the scope of this project, but hopefully maybe here are people who could do it.
Any other?
So for pine, was the basic density the quality parameter that you were kind of looking for?
Well, it is related to the density, the early growth rate, but it's related also to the branch formation. So it's related to how low are the first branches and like the strong ones, and that way to the quality. But I don't know, maybe it would be good to get the density information also. I think that by the electrical impedance it would be possible.
What about the annual ring width and decay? Did you investigate those?
We haven't got the results yet. It seems that we didn't get too many decayed logs. So too good material for that research. But we have measured with the electrical impedance spectroscopy, we have measured some decayed trees also, and it seems possible.
Maybe easy to find that kind of data from spruce data.
Yeah, hope in the other project it might be possible.